If you regularly use AI chatbots, you have likely run into the exact same frustrating wall. You type a request, and the machine hallucinates or stubbornly gives the wrong answer. It feels exactly like pulling a lever on a slot machine. The common assumption here is that we are simply powerless. When the chatbot spits out nonsense, we assume it's an engineering problem, and our only option is to sit back and wait for the developers to patch the system or release a smarter model. That assumption drives people to buy magic prompt libraries, hoping someone else has cracked the code. But pasting a supposedly perfect viral prompt into your own chat session often yields a completely different, completely useless result. This diagram visualizes the core truth of large language models. They are probabilistic engines, calculating outputs on the fly by navigating infinite pathways based purely on chance. But these calculations are fragile. Hidden variables immediately corrupt the pathway, and the final response is altered entirely. Treating a language model like an all-knowing oracle leaves your results entirely to chance. The unpredictability you experience is a mechanical failure of your own inputs, not a personality flaw of the AI. Imagine you hire a handyman for a broken door, and you simply tell them to fix it. Without specifying the budget, the specific materials, or the paint color, you leave the interpretation entirely up to them. You might get a crude wooden patch, or you might get a massive steel vault. Human experts cannot read your mind to fill in missing parameters. A predictive text engine certainly cannot. The broader your request, the wilder the variation in what you receive. So we naturally try to overcorrect. When the AI fails, the instinctive reaction is to type out massive, rambling paragraphs, adding a dozen different commands to over-explain exactly what we want. This diagram shows what happens to the probabilistic engine when you do that. This is prompt bloating. Screening endless, conflicting instructions at the AI does not clarify your request. It jams the system and scrambles the engine's ability to calculate a clear path. To eliminate the chaos, we have to stop adding volume and start applying deliberate structural constraint. You have to force the engine into submission. The first layer of structural constraint is the informational boundary. Think of this as defining the macro-level map for the AI. This visualization illustrates how a persistent context works. Whether you use memory features, identity files, or custom instructions, you are drawing a hard perimeter. You are explicitly telling the AI that it is operating in New York, not London, immediately shutting down millions of irrelevant calculations. But a map is only the starting point. You can still get lost inside that boundary without an exact GPS route. That requires the second layer, the interaction boundary. Unlike persistent context, the interaction boundary is deliberately designed, step-by-step constraint. You define the exact route, intentionally cutting off every alternative option before the AI can even consider it. By giving the system highly specific rules on what to execute and what to ignore, you choke off the branching pathways. The engine has no choice but to follow the single track you built. When you combine a strict informational boundary with a precise interaction boundary, you mathematically strip away the variation. The output stops being a game of chance and becomes a predictable, deterministic path. Generating consistent, accurate results is a matter of deliberate engineering. It relies entirely on your input structure, regardless of which specific AI model you are using. This blueprint outlines the AI Gaji framework. It is a formalized, step-by-step system designed to help you build these deterministic paths logically, without needing a background in coding or overly complex rules. The framework also includes a dedicated prompt analyzer tool. It automatically scans your text, diagnoses structural flaws, and engineers the missing constraints into your prompt for you. You can learn to build these constraints yourself by joining the comprehensive AI Gaji Framework course, or you can take the streamlined 2-hour intensive workshop. For the next 3 days, you can apply the promo code AIGAJI25 at checkout to secure a limited-time discount on either option. We are also offering completely free preview sessions on April 22nd and April 30th. Registration links for the preview sessions, the course, and the workshop are all down in the description. Mastering the mechanics of constraint gives you total control over the engine. You stop gambling with a slot machine and start operating a precision instrument that flawlessly executes your exact intent.